Hi everyone, I'm John Mugo and I'll be taking you through Introduction to Relational Database Concepts. Okay, so in this lesson, we'll be able to cover the following objectives. We'll be able to define a primary key, a foreign key, a column integrity rule. We'll be able to also identify row, column, primary key, unique key, and foreign key elements given a diagram of a table containing these elements. We'll also be able to identify violations of data integrity rules. So the purpose of this, of what we learned today, is the conceptual data model will be transformed into a relational database design. So the first step you usually come up with is the data modeling. That is usually the first step. The second one is coming up with the database design, and the third one is being able to develop the database. Okay, so this means that our entities, attributes, relationships, and unique identifiers that we're able to come up with in the data model will be translated into objects in a relational database. So compare this to a clothing designer who is taking his design from paper and implementing it with fabric. The designer needs to understand how to sew the designs, just like you will need to understand the structure of relational database objects. So when you have a scenario, for example, you'll have to identify the entities, the attributes, the relationships, the unique identifiers, and you'll be able to draw the ERD diagrams even on paper, like at first, before you come up with the final design, which now you'll be able to you can be able to come up with maybe using a software. And then after that, you'll be able to develop a database for yourself. Okay, so relational database illustrated. A relational database is a database that is seen by the user as a collection of two-dimensional tables, each containing rows and columns. So the table below contains employee data. So in this case, employees is the entity, and employee ID, first name, last name, and department ID are attributes of the or of employee table. Okay, so basically, as we are seeing here, it is a relational database. Is a database that is seen by the user as a collection of two-dimensional tables. So you'll find that there's table A, which is employees, and then as you can see here, this is department ID. Department ID is from another table called department. So department ID is a primary key from another table called department, whereby there's department ID, department name, and all that. But as when it comes here, this department ID, it is a foreign key when it comes to table employees. And using this, you can be able to derive data such as, maybe if you want to know all the employees who are in department 90. You see, so you'll have to combine these to join these two tables, and we'll see that we usually do that using SQL, the querying language for databases. So we'll see that you'll have to combine the two so that you can be able to get information as such. So let us see that from the next slide. So language to access data. So structured query language allows us to access data in relational databases in an efficient way. Okay, so there are many languages, so SQL is just one of them. So instead of manually searching through each row to find the record for employee number 200, we can use maybe the following SQL statement. I don't want us to focus on the statement as such, since we have not yet gotten to this topic. So the purpose of this example is just to show you how we usually get information using SQL. Okay, so for example, this SQL statement over here helps you to come up with it helps to select the last name and the department ID for employees where the department ID is 200. So as you can see from the result here, you'll see Wallen, and he's from department ID 10, and his employee ID is 200. So basically, that's how SQL help us to query and come up with such information. So don't focus on the SQL statements right now. We'll learn that later. So, and also this one, another example, to find all the employees in department number 90, we'll write a different SQL statement. So, yeah, and you can see it's finding employees in a department, and department is a different table. So as you're seeing, we'll have to combine those two tables. And as you have seen from here, it says here, a relational database is a database that is seen by the user as a collection of two-dimensional tables. So we have table employees and table department, whereby if you want to get information about an employee who is in a certain department, you'll have to somehow combine the two using maybe the foreign keys. Okay, so using department ID's primary key, you'll bring it to employee ID as a foreign key. Okay, so as we are saying, there's another example. To find all the employees in department number 90, we write a different SQL statement. So don't focus on the SQL statement. We'll learn about that when we get to SQL. So here you will get all the employees who are in department number 90. So as you can see here, this is the result. It will list for you all the employees and the information who are in department 90. So basically that's how we usually use SQL to come up with such records. Okay, so a primary key is a column or a set of columns that uniquely identifies each row in a table. So for example, you can say the primary, this one has, it's a multiple column primary key. I know that we said primary keys are unique, but if you see here, account number, all these this one, like this one is this one is different. Like this, even if there are two, there's no point you'll find that maybe here it's 104 and 75 760 and again 104 75 760. Okay, so primary key, we can find situations whereby you have more than multiple columns, and you can have situations whereby you have a single column primary key like this one, it's only one. But as we will learn more about that as we continue. So each table should have a primary key, and a primary key must be unique. So yes, as you can see from here, this is a single column primary key, and this one is a multiple column primary key. They're unique, and there's no way you'll find, as we've said, the same 104 and 75 760 again 104 75 760. Okay, so each transaction is definitely is different from the other. Okay, but we'll learn about this multiple column primary keys as we proceed. So no part of the primary key can be null. Okay, so null means they cannot be empty basically. Okay, so they must have in records. So primary key candidates, a table can have more than one column or combinations of columns that could serve as the table's primary key. So each column or combination of columns is called a candidate key because it could be selected for use as the primary key. Yeah, so as you can see here, we have candidate keys as well. So when a table has more than one column or combination of columns that could serve as the table's primary key. So both the member ID and payroll ID can serve as the table's primary key. So this one is a candidate key, and is also a candidate key. You can also say the same when it comes to this example. Okay, since they are multiple. Okay, so select one candidate key to be the primary key for the table. The other candidates become alternate keys or unique keys. So you can choose this one to be your primary key, and then this one will be an alternate or a unique key. Okay, so let's move to the next part, foreign keys. So a foreign key is a column or combination of columns in one table that contains values that match the primary key value in another table. So when you're talking of foreign keys, as we had seen, as I was trying to explain to you earlier, we have the employees table and we have the departments table. Okay, so you'll find for the employees table, you have employee ID, first name, last name. Just leave department ID for now. When it comes to the departments table, you'll have department ID and department name. So when you want to query, as we had seen earlier, maybe an example, all the employees who are in department ID 90. So how will you be able to do that when the tables are separate? You will add another column in the employees table whereby you'll use the primary key, department ID. But once the department ID, now the primary key from the departments table comes to the employee table, it becomes a foreign key. So basically, a foreign key is a primary key in another table. So as you can see from this, so in one table that contains values that match the primary key value. Okay, a foreign key is a column or combination of columns in one table that contains values that match the primary key value in another table. So when you see this one as a foreign key, definitely it's a primary key in another table. And we use that, especially when you want to query it. You know, the two of them have a relation. Okay, so foreign key rules. If a primary key is composed of one or more foreign keys, the foreign key cannot be null. Okay, so if a primary key is composed of one or more foreign keys, the foreign key cannot be null. So as you can see in this example, shelf number is a primary key here. So when you come here to this side, so if it's shelf number and book number, these are two primary keys. No, these are two primary keys, sorry. The foreign key cannot be null. Okay. Yes, so a column must contain only values that are consistent with the defined data format of the column. Okay, so a column must contain only values that are consistent with the defined data format of the column. So this is about data types. And when you look at the LMS, we'll have a department, and we'll have a section whereby we'll have notes on the data types, the most common data types and how they're used. So yeah, I don't want us to focus more on data types right now, but you will see that we will share that. Okay, so when the summary of data integrity rules. So data integrity rules, also known as constraints, define the relationally correct state for a database. Data integrity rules ensure that users can perform only those operations that leave the database in a correct and consistent state. Okay, so you can go through this summary. So entity integrity. So a primary key must be unique and no part of the primary key can be null. An example, the column employee number in the employees table cannot be null. Referential integrity. This one is a foreign key must match an existing primary key value or else be null if nulls are allowed. So the value in the department number column of the employees table must match a value in the department number column in the department table. Okay, so if you have a foreign key somewhere, it must be a primary key in another table. A column integrity. A column must contain only values consistent with the defined data format of the column. So the value in the balance column of the accounts table must be in numeric. So for example, in accounts table, as you are seeing here, so if it's the bank number, the data type is number. If it's account number, again, the data type is number. If it's the balance, it's number. If it's date opened, it's date. Maybe if you have name and maybe the name here, name, for example, the data type of name, you can use a variable character or character, but we'll share something on data types. Okay, so user-defined integrity. The data stored in a database must comply with the rules of the business. So if the value in the balance column of the accounts table is below 1, we must send a letter to the account owner. This will need additional programming to enforce. So the rest, we're going to learn more about this as we proceed. When we get to coming up with ERDs, we'll understand how this works perfectly.